delegates watching this video, a warm welcome. Through this video, we'll be explaining the physics behind the various tourist attractions in Himachal Pradesh. The participants are Siddharth P, myself, of 12th Science, explaining the physics behind paragliding with the help of a beautiful diagram drawn by Kishan P of 12th Science. Kishan P of 12th Science drew a picture of the physics behind the paragliding. K. Ansar of 12th Science explained the physics behind ice skating. Suraj Rajan EP of 12th Science, he made a model of Chicham Bridge. And Kiran P of 12th Science explaining the physics behind bridges by using the model made by Suraj. Now let me get right into my topic, that is the physics involved in paragliding. First, let us take the example of a ball. We throw the ball up in the air. It goes up and comes right down into the ground. That is because Earth pulls everything towards it with a special force called gravity. Now if you throw a stone and a feather at the same time from a skyscraper, gravity pulls them towards the ground at exactly the same rate. And to add it all up, if there were no air, then the stone and the feather would have fallen into the ground at the same time. First, let us take the example of a ball. We throw the ball up in the air. It goes up and comes right down into the ground and catches in the air as it falls to the ground. So air resistance or drag slows it down. Now a related question for this theory will be, what is air resistance? Earth's atmosphere is packed full of gas molecules. So if you have to move through air, we have to push them aside and then move. Well, we only really notice this when we are actually moving. Air resistance is a bit like water pushing our body when we are actually swimming. But air is invisible. When we move through water, we part the molecules of water slowly in front of us. But in parachutes, we need to glide through them. We need air resistance. Let us take another example. If we fall from a plane without a parachute, our body zooms through the air like a stone, a weight stone falling from a great height. Now, if you open our parachute, we create more air resistance or drag, and we drift to the ground more slowly and safely. Simply speaking, parachute works by increasing the air resistance as we fall. Now, another important term in the physics of parachute or paragliding is of course the terminal velocity. When a force pulls on something, it makes the object to move more quickly, causing it to gain more speed. In other words, gravity makes every object to fall more quickly but up to a certain speed. That speed is known as terminal velocity. Now, to the final part. How does a parachute work? Parachutes are 3 chutes packed into one, and that package is known as a container. There's the main parachute, the reserve parachute in case of emergencies, and a tiny little chute known as the pilot chute. And this small little chute helps the main chute to open. The main chute is designed to open in a delayed way so that your body doesn't break or jerk too sharply and damage our body. Pretty much that is more safer and smoother for us, and also it helps in the parachute for not tearing up. That's pretty much about the physics in paragliding. Hope everyone liked it and also got something from it. So let's now move on to the next topic.
Mr. Science, I am here to speak on the topic of ice skating. where I will be explaining about the physics involved in ice skating. So, do you know what is skating? Skating is done with the help of pair of boards called sky and a pair of support called sports. This sky is made in such a way that there is a good contact with ground and equal distribution of weights towards the ground. Skating is done on snow. Do you know what is the reason? The reason is snow has very less coefficient of friction as compared to other solid resistance. So that is, snow offers very less resistance to motion. When the person at the top of Helen, he is at higher potential. To start motion, the person need to push his poles towards the ground to get reaction force to overcome inertia. And once the person overcome inertia, he moves continuously under gravity. So to increase the speed of skiing, people used to pull their body together in a steam-like position. This position offers less air resistance. A lowering of body center mass also ensures better stability. And at curve, the person inclines herself towards ground, opposite to the curvature of path. And this increases horizontal path or horizontal component of velocity of that person. And at last, to stop moving, people will align their feet in V position, and this position is called snowplow. This is to make horizontal component of velocities in opposite direction and allowing them to cancel each other. So that's all about physics of ice skating.
Myself Kiran P, and I am here to talk about the topic forces acting on a suspensional bridge. There are mainly two types of forces acting on a suspensional bridge: external force and internal force. First of all, talking about external force. External forces are divided into two types: static force and dynamic force. Static force. Static force refers to the weight of the bridge itself. The bridge may collapse due to the gravitational force acting on the material of which the bridge was made. Dynamic force. Dynamic force refers to the traffic moving across the bridge and certain environmental conditions such as change in temperature, wind speed, precipitation, etc. And now talking about internal forces, they are divided into four types: tension force, compression force, torsion force, and shear force. Tension force. Tension force is a pulling force that acts on the cables and suspenders of a suspension bridge. An example of tension force is when we pull an elastic band, we can see a force acting on it. This is tension force. Now the second one is compression force. Compression force is a force that acts on the towers of the suspension bridge. An example of compression force is when we compress a spring, it will become smaller. This is due to the compression force. Torsion force. Torsion force is a twisting force that can be seen when suspension bridges are put under high wind speed. The bridge may move or twist if these forces are never taken under consideration. An example of torsion force is wringing a cloth. And the last force is shearing force. Shearing force is a force that occurs when pushing or pulling of forces occurs in opposite direction. It may cause the bridge to bend or break. In suspensional bridge, the towers and cables experience an opposing force, which may lead to break or bend of the suspensional bridge if these forces are never taken under consideration. An example is, consider a tree standing in ground. If a high speed wind come and hit it, it will break. This is due to shear force. So these all are the forces that should be taken under consideration while building a suspension bridge. If not, it will break or bend and it will cause severe damages to the citizens living nearby. Thank you.